So we're looking at proportional relationships and with graphs. This is a lot to do with still constant rate of change. And now we're going to put it with the graphs and how it all kind of looks together with the table, the rate of change, and graphs. So once you get this into your table of context, please put on page 97 or your next following page that you are at in your journal. Okay, as you can see, I am just right where we left off because it all kind of goes together, but this is proportional relationships and graphs. The graph of a proportional relationship is a line that passes through the origin. The origin is 0, 0. It's where your x and y value intersect, and that is at 0. So your horizontal, wherever that 0 falls, if it's right here, then your x or your y will go through that vertically, and your x will meet the y's 0 and cross at that point. So your 0, 0 is what's called the origin, and you should have previously learned about origin in a previous grade level. Okay, an equation of the form y equals k times x represents a proportional relationship where k is the constant of proportionality. Sorry for the interruption, guys. All right, the interruption is over, so we're going to continue. Once you get that into your journal, we're going to do a table and a graph on the next page. All right, so before you get all that, let me adjust. All right, so from our table, when you're given a situation, say I'm trying to figure out how many sandwiches I can make from so many tablespoons of peanut butter. So I have figured out that it takes 6 teaspoons of butter to make 2 sandwiches, 9 for 3, 12 for 4, 18 for 6, and 21 for 7. You still have a constant rate of change that you're looking at, y over x. I'm not going to figure that into this right this moment because we're just looking on how we can see the graph, and I have that covered up. From the table, your x value is on top and your y value is on bottom. You can make your ordered pairs from here, x and y. So we have 2 to 6, 3 to 9, 4 to 12, 6 18, and 7 to 21. Remember, your x is your horizontal, y is your vertical, so you always want to do x before y. All right. Here we are going to start doing our table where we have our y value is the peanut butter, okay, in tablespoons. And I have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. Every other line is worth 6, or every line is worth 3. So 3, 6, 9, 12, 15, 18, so on and so forth. Okay. Again, your origin is where the lines intersect at 0, 0. Your x value is your sandwiches, and I kind of just eyeballed my spacing, tried to stay as close to my actual spacing for my lines. And you're going to do single digit ones, 1, 2, 3, 4, 5, 6, so on and so forth. Okay. At this point, you would plot the points in your graph. I'm going to go ahead and uncover it. It gives you a lot more information than just the line, but you're going to go through and read all of the information to you. So we're taking the table from above and we plotted the points to make a line. Okay, those are the dark black circles. All right, here's my 2. So I went over to the right 2, then up 6, 2, 6. We have 3, 9, 4, 12, 6, 18, and 7, 21. All right. What I can determine from this is that I can go up 3 and over 1, and that is my constant rate of change. Okay. A line through the points passes through the origin, which shows a proportional relationship. Notice that this line could start at 0 and it goes through all the lines. And since it goes and starts at the origin or goes through the origin, it is proportional. It has a proportional relationship, which means it does have a constant rate of change if we'd figured it out. Again, we could then state that the constant rate of change, 6 over 2, 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. That is our constant rate of change. So when all of these are the same for our constant rate of change, that meant we had a proportional relationship. So now we're just looking at it, what it looks like in a graph. Okay? The point represents the amount of peanut butter in tablespoons used for sandwiches. Okay, that's really what these points are representing, is just the representation of the table. All right, last but certainly not least, to wrap up this, in order to be proportional, two things must happen. One, the rate of change, K, must be constant, and that's what we learned yesterday. And two, has to go through the origin. This line, the representation of the points from the table, has to go through the origin. If neither one of these happen, then it is not proportional. Tomorrow, be ready to look at some examples in class. First half of class period, we'll be working on a lot of these together, and then you'll have your independent practice to work with yourself to make sure that you are understanding this material. If you have any questions, please make sure you write those down in your journal and be prepared to ask them in class and discuss with others in class. Y'all have a good night. See you tomorrow.